If you want a quick introduction to Android Studio Android development, then you're in the right place. It's assumed that you already have some understanding of basic data types and maybe even object orientation, but are not really required. So if we start Android Studio and select File New Project, you'll be given a list of templates and you can select the one called Empty Activity. On the project details pop-up that follows, we need to enter a name for our project, so just give it something constructive and unique. A package name, which is really just a technical identifier. It will usually use your company's domain, but just make sure it's something unique. Make sure the language for this project is set to Kotlin, and it's also possible to select which Android SDK version you're currently going to use for the project. Just leave the default one selected. This is the main screen for Android Studio that we're going to be using. On the left is a file tree that lets you see all the individual files, layout files, code files, etc. The middle is the code window where you can manipulate it just like a normal text editor. And on the right, we should have an emulator. If we now build and run the application, we have the default application running in the emulator, Hello World, and nothing else. But at least we know that the application builds and will deploy to the emulator, so we can start to modify it now. Right, let's add some images. Okay, so let's make the application a bit more presentable by adding an image. If we look at the code that's present in main activity, we can see that the content view that is set is r.layout.activity_main, which defines what is displayed in our application. This can be opened by either holding Control/Command and clicking on it, or by selecting it in the Res Layout folder in the left-hand panel. Once open, we should be able to see our existing text view. We can also see how the text view is a child of constraint layout, which in this case is just basically a container or a box, handles how the views within it are positioned. There are a number of layout types, but this one allows us to constrain our views relative to the layout itself or to other sibling views. As we can see by the blue wavy lines, the text view is constrained relative to its parent, which is actually the constraint layout. We can see the anchor points on the text view have been connected this way. If we enter an image view to hold our picture and make the width and height wrap_content, which means that the view itself should just be the same size as the picture we load into it, we can now define which image is displayed by adding an Android::source property to the view and setting it to @drawable/IC_launcher_foreground. The @drawable means it is getting the actual image from the res/drawable folder, and the IC launcher foreground is the file name of the image. In the design window on the right, we can now see the picture loaded in, although barely as it's white on white for now. You can now drag the constraint anchor points to align them with the text view. Drag the bottom one to the top of the text view and the others to the bounds of the main window, which is actually the parent constraint view. The small picture should now be aligned to the center between the top of the screen and the text view. We can also supply the image view with an Android::background property that works in the same way as the source property, but with a background image. This now makes the picture more prominent as it's got both a foreground and a darker background image. To make the picture conform with accessibility requirements, we can add a content description to give textual representation of the image. If we go to the strings file, which is in the res values folder, we can add a description there. This file allows easy localization of text. Multiple versions of this file can be supplied if required, one for each language. The localization and content description approaches get us off to a good start with a professional approach, rather than just typing in the string where it is required, which will make it more difficult later on to localize the application. As with the drawables, retrieving anything from the resources requires a prefix of @string, this time followed by the name of the string we just defined in the strings.xml file. Run the application again so that it rebuilds, and we should now have an Android head on a green background with the Hello World text still in place. So now that we've got something to use on the screen, let's add some functionality. we're going to add a button that lets us change the colour of the picture. Add a button with width and height set to wrap content as before in either the code window or drag and drop in the design window. We need to add some text to the button, so use the Android text property and add a string to display in the strings.xml file as we did before, such as press me. Then add the constraints of the button to centralize it under the Hello World text view. Build it and run it, and we can see a clickable button that currently does nothing. Let's resolve that. Okay, add a property to the button called Android on click. This will allow us to add some functionality to the button. Just give it a suitable name. Android Studio is intelligent enough to realise that you need the function in main activity. Select this in the drop-down. Change the open file to main.activity.kt and you should be able to find the function with the same name as you just added to onClick. This function should now be called automatically whenever the button is pressed. If we expand the parentheses, we can add some actual logic to the method. The view parameter supplied in our case will be the button. View is just a generic type for all views and not just buttons. As this function can be used for multiple buttons, it's always good practice to make sure that we're performing our actions on the correct one. We can test if the view's ID matches our button by setting an ID on the new button and comparing the supplied view. Now we can use the button to modify one of the other views. A function called findViewById already exists as part of activities, of which main activity is one. This can be used to find references to other views if required. We're going to use it here to find the original text view. Supply the view type in angled brackets so that Kotlin knows what type of view it's dealing with. We can access it by using the r.id.textView. R is generated by the system and allows us to access images, strings, views, etc. After this method, we can use the safe call operator, which is basically a question mark, that allows us to modify the view if it exists, but ignore the operation if it cannot find the view. Then add the text view method, text becomes equal to pressed. We can now run the application, and when the button is pressed, the Hello World text should now change to pressed. Now that we've got a function set up to handle button clicks, let's make it a bit more interesting by changing the colour of the Android image. We need to add an ID to the main image view so that we can access it in the same way as the text view. Give it a useful name. It's always best to avoid image 1, image 2, etc. In the main activity code file, we now get a handle on the image view itself by using findViewById again. Don't forget to set its type in the angle brackets to image view. Image view has a useful function called setColorFilter, which will allow us to change the colour of the image type we are using. If we apply a colour here, it should overlay the new colour onto the image. Colour is a utility that already exists conveniently. We can use one of the colour values already defined, such as colour.red. Run the application again and we should be able to change the colour of the Android to red by clicking on the button. To make this a little more exciting, we can add some randomness to the colour. If we use the random utility, I chose the Java import when it asks which one to use. This will allow us to generate a random value for red, green and blue each time the button is pressed. Make sure to add our new randomly generated colour to the setColorFilter method of the image view. At the same time, we can get a handle on the text view rather than accessing it directly. Remove the question mark dot text and add a val text becomes equal to before the find view by ID. This way we can make multiple changes to the text view without having to call find view by ID repeatedly. We can update the text as before, but also set the text colour using our randomized colour. Build and run the application, and when you click the button, the image of the Android should change colour along with the text below it. This should display a different colour each time you click the application button due to the randomness we introduced. And as you've been curious enough to make it to the end, please consider subscribing to the channel. Thank you.